Let's work on solving and graphing inequalities. So a reminder, when we're solving inequalities, it's just like solving equations. The only difference is rather than an equal sign, you have an inequality symbol. So let's go ahead and start off with our basics of solving equations. Now we know our goal in solving equations or inequalities is to get the variable by itself, right? So in this case, we want to see g by itself. Now, in order to get rid of what's around g, or any variable, we always want to do the opposite, right? So in this case, we have g plus 45 is less than 58. We just want to know what g is less than. We don't want to know what g plus 45 is less than. So what do? We get rid of plus 45. How do we do that? Well, what's the opposite of adding 45? Subtracting 45, right? So if plus 45, if I had $45 and then I spent $45, I now have 0, went away. And I'm going to do that on both sides of the inequality sign. All right, so I'm left with g isolated. I'm going to keep my inequality sign. Remember, this isn't equals, it's an inequality, so it's going to be less than. And then I'm going to do the math. 8 minus 5 is 3, 5 minus 4 is 1. So I know that g is less than 13. And now that I have an isolated inequality, I could solve. Before I solved that, I can graph, Before I solved that, I wouldn't be able to graph because I need to know what that isolated number is. So I'm going to put that isolated number 13 near the center, and I'm just going to build up a few, and I'm going to build down a few values. All right, now we need to understand the principles of graphing. Remember, we have two options, an open circle or a shaded circle. Anytime we have open circle, it has to be the greater than or less than symbols because it does not make the inequality true. Whereas if it's a shaded circle, it's greater than or equal to or less than or equal to because it makes the inequality true. Let me give you an example. If I plugged in 13, is it true that 13 is less than 13? No, it's not. That's why I have an open circle. But if it was less than or equal to 13, it would be true that 13 is less than or equal to 13. So that would have been shaded. All right, and then g is less than 13. Remember, if it looks like a scrunched up L, that means less than. I want to graph all the solutions that are less than 13. So I should be going to the left here. If you're using the little graphing trick, anytime the variable's on the left is the only time this works, but the arrow will actually point in the direction that's shaded. See how it's pointing to the left? Because anything less than 13 is a solution. And then if you were unsure if you were graphing correctly, you can just take a value from either side and see which one makes it a true statement. So for example, if I plugged in 11, which is on the shaded side, is less than 13, is that true? Yes, 11 is less than 13, right? The mouth always eats the bigger value. But let's say I accidentally plugged the other side or shaded the other side. I wanted to check it. I would put 14 or 15 in place. 14 is less than 13. Is that true? No, 14 is not less than 13. It's actually bigger. So I know that that right side should not be shaded. Okay, hopefully that helps you.